Hello and welcome to Gauder Akustik. My name is Dr. Roland Gauder, and today we want to talk about a new technology we have in our loudspeakers.
Yes, nice to have you here again. My name is Volker Specht, from Gauder Akustik also, of course.
Of course.
And what are we going to talk about today, Roland?
We talk about the thing we call time delay control, TDC.
TDC, time delay control, okay. But Roland, in my opinion, this is not only a new feature, it's a game changer.
Yes.
A real game changer.
And I think we are the first ones in history in hi-fi that did this in our loudspeaker.
I don't think so. I'm sure we are.
You're sure? Yes, we are, yes.
Yeah. Okay, Roland.
Yeah.
TDC.
TDC.
Please tell us what's the story behind.
Yes, actually it's not a new problem in hi-fi. It's well known for many, many years because since the 60s we just always make constructions of two-way, three-way and four-way speakers. And so we need a frequency crossover inside the loudspeaker to direct the right frequencies to the woofer, to the mid-range and to the tweeter. And with this we have the problem that there are inductors inside the frequency crossovers, and inductors delay the signal.
So please let me ask, because I really want that everybody understands what we
Yes.
are talking about. So we talk about capacitors, inductors and resistors. So
That's true.
these three things, let me tell it like this.
The components in the frequency.
Components, thank you, better word, are on every frequency crossover.
Yes.
And we need them.
Yes, because we need a low-pass system for the woofer and the mid-range to stop them from radiating sound in the frequency range where they are not able to do the right thing.
Okay.
And so we have inductors in the frequency crossover, and I want to show you how they work on the next diagram.
Okay, Roland, please show us what means this from the technical side of view.
Okay, so let me draw a diagram here. We just have two axes. As always, the horizontal axis is the frequency.
Yeah.
But now we do not have the amplitude, but we have the time with delay of the whole system.
So TD, time delay. Huh?
Time delay. And we see that in the low frequency area, we have a high time delay. Then the mid-range is coming, it's constantly flat, and then it changes to the tweeter. And so you see the bass has a big delay, but actually that's not a big problem because natural instruments have a long time to get into the vibrational state, and so this is not very critical. But the difference between the mid-range and the tweeter is big. And to tell you something about the time delay in seconds, it's normally between 0.3 to 0.4 milliseconds.
So let me ask one thing, please. This one here is the crossover point between the bass and the
Yes.
mid-range, and this one here is the crossover point between the mid-range and the tweeter.
Yes.
Okay. So Roland, in other words, please, may I?
Yes.
It would be perfect if it would be like this.
Yes, absolutely. Here we have a straight line, and there is no time delay between the mid-range and the tweeter. And so they shoot at the same time, and we get the perfect impulse response.
This is not a new problem, isn't it?
No.
Because I saw many constructions on the
Yes.
market where they do geometrical adjustments,
Yes,
I would
yes,
call
yes.
it, with the tweeter.
Yes.
So on some loudspeakers you see the tweeter is a little bit more behind than the mid-range or the bass.
Yes.
Sometimes you see the baffle going like this, then the tweeter is a little bit
Tilted, yes.
tilted
yeah,
or something.
I know.
Yeah. So this is geometrical. Why don't you do it like this?
Yeah, well, let's just check how much this is in length. The time is 0.3 to 0.4
That's
milliseconds.
nothing, isn't it?
That's about 10 centimeters.
It's 10 centimeters.
Yes. And so if you just take a small board with 1 centimeter, it doesn't help at all.
Doesn't work,
no,
huh?
it doesn't work. You need to shift the tweeter back about 10 centimeters to coincide the impulse of the tweeter with the impulse of the mid-range driver.
But then I will ask you, why don't you do it?
Yeah, because you can imagine, if I take the tweeter,
So this is the top of the speaker,
it's
huh?
top of the speaker,
Okay.
and I take the tweeter and put it back, what do I get? I get, of course, a direct radiation to the ear, but I also get reflections from many points of this plane here. And so I have secondary and tertiary sources of sound. And these sources all interfere at the ear, and they cancel out. And also, of course, I try to correct the time response of the speaker with this shifting back, but actually it does exactly the opposite thing. The reflection and diffraction effects are too worse. And
it's only one frequency, isn't it?
it's only one frequency, yes.
Okay. But in other words, with geometrical things, with geometrical adjustments,
Yes.
you cannot solve this.
No.
Can't you?
No, of course not. You just can shift the tweeter back, but then you have just a correction for
And
only
you
one
get
frequency.
other disadvantages.
Yes, yes,
So
absolutely.
how do you do it, please?
Yes, of course. No, you just look at the diagram and you say, okay, if I would have a function which is complementary to the green one, and I add these two together, I get the blue straight line. So if my tweeter would have a time delay according to the red function, I would absolutely correctly solve the problem for any frequency.
So you do it from the electrical side. You
Yes.
do it with electrical components on the crossover network.
Yes, absolutely. That's the only way you can create such a transfer function, such a filter function.
It sounds simple. Is it simple?
No, that's not simple to calculate.
calculate?
No, it's not
No?
simple to calculate, because there is also the high pass filter of the tweeter, which has to be considered by the whole calculation. But I did it.
But you need a lot of capacitors, inductors and resistors for it, don't you?
For the time delay, I need 5 components.
Okay, but you need a crossover too.
Yes, and the crossover too. And so we have 18 different components for the crossover only for the tweeter.
But Roland, let me tell you, I'm on the phone the whole day.
Yeah.
Many people ask me on the phone,
Yeah.
why do you dead filtering? Why do you do dead filtering the sound with so many components in the sound way, or something like this? Did you hear that? Did you hear that also?
Yeah, I heard it on a lot of shows in the last 20, 30 years.
What do you say to these guys? What do you?
Yeah.
What is the physical answer to this?
The people always think that a frequency crossover does a bad thing to the music, but actually it's the totally different way. You know, people always tell me, our resistors, they make the music slow.
Yeah,
so
I hear this all the time. I hear this all the time.
They think a resistor reduces the speed of light.
Exactly.
But actually, that's nonsense. Also, it's nonsense that capacitors and inductors dissipate energy. They do not. And so they are only imaginary resistances with impedances, and they do not dissipate energy.
Okay, Roland, but let me ask you again one question.
Yeah.
What is responsible for the efficiency of a loudspeaker? If
okay.
it's not the resistor or the conductor, what is it? What is it?
Actually, the two things which are responsible for the efficiency of a loudspeaker is the F3 point, so that means the end of the low
How low can you go?
How low can you go with the drivers, and the volume of the whole cabinet. If I have a big telephone booth, of course I can get a high efficiency. Or if I don't want to go down to 30 hertz and say just 60 hertz is enough, then I would have the 8 times of the efficiency. And so you see, it's easy. If you want to go down low, and of course we want that. And if you don't want to have a telephone booth in your living room, then you must decrease the efficiency.
So please let me talk in Gauder Akustik
Yeah.
language. It's not the thing of the power of the amplifier today. It's not the thing.
No.
But the thing is to
No.
get an absolute correct and fast impulse reaction and an absolute correct phase and time correction.
Yes.
This is the game changer.
Yes, and that's what we do with this TDC circuit inside the frequency crossover. We delay the tweeter so it coincides with the mid-range driver.
Okay, Roland, but
Yeah.
for the audience, many mathematics, many physics,
Yes.
but did you verify the things we say?
Yeah.
Can you prove it?
Yes, that's what we always do in physics. We may have a theory, we calculate something, and then we make an experiment and we try to verify the predictions we made. And I did it too. I built 2 pairs of speakers which were exactly the same, but one with the time delay control circuit and one without.
Oh, I remember that day. I remember that day, Roland. I remember exactly that day. But excuse me for interrupting you. Please go ahead. I remember that
I
day.
remember I ran out and said, come in, you must hear this.
Yes. And you
Yes.
told me, please hear this game changer. Please hear, I think it was a Dark 100.
It was a Dark 100,
It was
yes.
an old Dark 100,
Yes.
so a MK1, I would say,
Yeah.
and the new one, the MK2
Two.
with the TDC.
Yes.
And you told me, please listen to this speaker. And I say, hey, Roland, I got no time because it was a very, very busy day with many emails, many phone calls, many
like
customers.
usually.
Like usually, yes. But this day, oh my God.
And you came in,
Yeah.
you sat down, and I couldn't get you out anymore.
I heard 2 or 3 hours music. I remember exactly. And I want to tell to all those guys over there, what is the difference in the sound between the TDC and non-TDC?
Yes.
You want to know what is the difference in the sound? You don't know, they want to know, huh?
Yes, but from a technical point of view, I can tell them, but I just want
And
to...
they want to hear music. You also want to hear
Yes.
music. So I tell them,
I want to hear that people really get the emotions that you had
Yeah.
while listening.
Yeah. I wrote it down on a sheet of paper.
Okay, yeah.
Because it's so many things, you know?
Okay.
So, first things, as we always tell on Gauder Akustik, and may I say, impulse response was at all the time at Gauder Akustik a big thing. But with the TDC, it goes to another level.
Yes,
so
exactly.
Impulse response, bam, the attack of the speaker. It's
Yeah.
so fast and it's so precise and it's so correct.
Yeah. Mm-hmm.
Spaciousness.
Yes.
Of course,
Yes.
when everything is correct and right, and the impulse response is absolutely correct, then you have a fantastic space. You have so much room. You don't see the speaker anymore.
You have a stage imaging which is absolutely
perfect
natural.
stage imaging.
Perfect illusion of the
You
sound.
lose the speaker. So when you close your eyes, there are no more speakers, there's only music. And the music goes from the wall to the wall.
Yes.
It doesn't
Yes.
end at the side of the speaker. It goes from wall to wall. Better localization. So you can exactly hear, or may I say, see, where are the instruments located on the stage.
Yes. Yeah. It's a very important point.
Transparency, of course. And for me, very, very exciting point,
Yeah.
that the colorization of the sounds is more natural.
You mean there is no coloration of
There is
sound? and
no colorization. Thank you very much.
Coloration of sound at all.
Exactly. There is no more.
Yeah. Mhm.
It's real.
It's real. It's a perfect illusion.
That's it. That's it. So, if you heard this for one time in your life, I can tell you, excuse me, there is no way back.
You get addicted to this TDC.
That's it. You get absolutely addicted.
Addicted
There
to
is
the
no
TDC.
way back. It's a real game changer. Roland, one
Yeah.
thing for the audience, which is in my opinion very important. In which series do we use this TDC, and is it always the same on a two-way system, on a three-way system, and the big ones are four-way systems?
Yes,
So
that's
please
true.
tell
yeah.
us.
So actually, we use the TDC in the Capello series, Berliner series, and the Dark series. And as you already mentioned, the Berliner series and Dark series, they also have four-way systems.
Yeah, the RC11 is a four-way
RC11
system.
of Berliner, or the Dark 250,
The Dark
500, four-way systems.
Yeah.
And so in four-way system, we have one step more here. And so we need one more TDC. We need two TDCs inside, a big one and a smaller one. One for the mid-range and one for the tweeter.
Okay. And of course, in those series, the effect, the thing you hear is more or less the same, but it also depends on the quality of the whole loudspeaker, of course.
No, of course, yes, we use different drivers and different crossovers.
Yeah.
And so we just have to adjust the systems to each series.
Okay.
But actually, the effect is always the same. We make a perfect time delay control of all the drivers in each series. And so you get the full information from Capello 40 to Dark 500.
So what should we say to those guys?
Please listen to our speakers and convince yourself about the quality of sound. But also, people, be aware, if you have heard it one time with your favorite tracks, you will be addicted to the system.
And always the same, Roland. Trust your ears.
That's a good final word.
Thank you.
Thank you.
Thank you.